Okay, so our objective for today, I can solve and graph quadratic equations. Let's read together. 1, 2, 3. I can solve and graph quadratic equations. So we're still on the same, we're still solving and graphing quadratic equations. The only thing today, we're going to go over a different way of solving them, and we're going to be using just square roots, which pretty much, to me, it just seems we're going to be solving using inverse operations. That's pretty much it, okay? So we already know what quadratic equations are, so we don't need the Fourier model for this. We know that there are two variable equations with the highest degree of 2, and we went over the steps also. We don't need the steps either. And we already know how to graph by using the vertex. Remember that? We identify the y-intercept and the x-intercept, which are our zeros. We graph all that, and we sketch the line of symmetry. However, today we're going to focus on step 5. So I want you to write step 5 on your paper. Write step number 5, and we're going to write the following. Step 5. Solve the equation and identify the zeros, which are the roots, or the x-intercepts. And there are two things that we're going to do today with that. We're going to isolate the variable and solve using inverse operations. Isolate the variable and solve using inverse operations. Those are the two steps that we need to remember. Isolate the variable and solve using inverse operations. Isolate the variable and solve using inverse operations. Tell your neighbor what we're going to do. Very good. All right. So yes. So by solving the equation to identify the roots or the zeros of the x-intercepts, we do two things. Isolate the variable and solve using inverse operations. Okay? All right. So with that said, copy this down. Example number 1, and copy the words that I circle. Copy the words that I circle. Solve using square roots. Right now we're just going to focus on this and copy this first example. X squared minus 169 equals y. Copy that. All right, here we go. Pens down, eyes up here. So notice that now we got into these equations that do not have a middle term. Now it's only a binomial on this side. You guys notice that. However, the first step is first. In order to solve a quadratic equation, we always change y into 0. So this becomes x squared minus 169. And when we get to that point, everybody look up, please. If I was to cover this part, bless you. If I was to cover this part, look at this. Does this look familiar? Yes, it's a binomial, number 1. Number 2, it's a subtraction, which makes it a difference. And all we have to do is see if it's a difference of squares. How do we check? Let me see. Can we take the square root of this? Yes. Can we take the square root of this? Yes. If we can, and it's a subtraction, therefore it's a difference of squares. So the factors are x plus 13 and x minus 13. And all of that equal to 0. Remember that? Okay. For those of you that don't, this is a refresher. From there, we set each one equal to 0. X plus 13 equal to 0. X minus 13 equal to 0. And then we solve. So here we subtract 13, subtract 13. X equals negative 13 plus 13 plus 13. X equals 13. And these are my x-intercepts, or my roots, or my zeros, and these are my solution. Is that correct? Okay, copy that, please. All right, so pretty much we solved this using the pattern for difference of squares, which we already did before. Okay? However, this is not today's lesson. This is just to refresh your memory as to what we used to solve before. Today's lesson is this. Everybody look up, please. Pens down, look up. And at this time, I don't want you to write anything. Just focus, please. I'm going to rewrite this right here. X squared minus 169 equals 0. Okay, you're just paying attention. So, to solve this, we're going to use inverse operations. So, what do I need to do to leave x by itself? plus 169 plus 169 to each side. We're left with x squared equals 169. What cancels this squared? Square root, square root. Notice that I'm doing inverse operations. Is that correct? This cancels this. X equals plus minus square root of 169. Copy that, please. All right. So this right here, we solved it. This is what they call it, solving using square roots. However, what did I say? It's solving using inverse operations, isn't it? Check this out. What do we do here? What is the inverse of minus 169? They add 169. What is the inverse of a squared? Square root. So it's just using inverse operations. And I'm going to show you the third way, a third way of solving these, just so that you have this in mind and that you know that the other way that we've been solving is by using the power rangers. Remember that? Or the diamond. So check this out. If I was to write this again, x squared minus 169 equals 0. What do you notice is missing from if I was to use the power rangers? What's missing here? The middle term, isn't it? So I can rewrite this as x squared plus 0x, because 0 is indicating that there are no middle terms. Are we there? And what is the last term? 169, negative 169 equals 0. So check this out. At this point, open two parentheses, factor the first term, use my Power Rangers, and what goes on top? Negative 169. What goes on the bottom? 0. So what numbers times the other give us negative 169 and add up to 0? 13 and negative 13. So x plus 13, x minus 13, set each one equal to 0, x plus 13 equal to 0, x minus 13 equal to 0, and from there we just solve. Minus 13 minus 13, x equals negative 13, plus 13 plus 13, x equals 13. And these are my roots, my x-intercept. Copy that, please. So let's look at what we just did. We got, let me minimize this. We got 3 different ways of solving that one. There's this way, using the difference of squares pattern. There's this way, using square roots. And there's this way, using our factoring using the diamond or the Power Rangers, right? So think about it. If whenever you encounter these equations, everybody look up, and you identify that it's no longer a trinomial, it's a difference of squares, which method would you like to use? Think about it. All right, and I'll leave it to you in regards to which one you use. But for right now we're going to practice more of this middle term, which is, the middle method, which is using square roots. Okay? All right, so with that said, copy this next one, please. Example 2. X squared minus 49 equals y, and let's work this one out together. Step 1, what is it? Change y equal to 0, so we're left with x squared minus 49. And let's use inverse operations. What's the inverse? Add 49 to each side. We're left with x squared equals 49. And what is the inverse of a square? Square root. Square root. This cancels this. X equals plus minus 7. Hands if you got that by yourself. Okay? Let's do another one. Do this one by yourself. X squared minus 121 equals y. Go. All right, let's see. Check your work. Here it goes. First step, you substitute y for 0. We're left with x squared minus 121. You add 121 to each side. 121. We're left with x squared equals 121. Our last step is to do the inverse of a square, which is a square root. And we're left with x equals plus minus 11. Hands if you got that. Okay. Now check this out. If I was to graph this, I ask you to graph it. Everybody look up. Here's my coordinate plane. What are my roots? Negative 11, positive 11. What is my y-intercept? Negative 121. And my parabola should look something like that. And according to our pattern, let's see, is it opening up right here with a positive coefficient? Yes. Is it going to cross through 121? Yes. And then there it is. Okay? All right? So, copy this next one, please. Example number 1B. X squared equal to 0. There is a root. Let's see. Let's see. How do we cancel this squared? Square root. This cancels this. X equal to 0. And you're saying, so for those of you that cannot picture that, here, let me show you. Everybody look up, please. What's my root? 0. That means it's here. And you're saying, so what would be my y-intercept if it doesn't have a constant? 0. So that means our parabola is crossing through the point of origin. It's both my x-intercept and my y-intercept. Now let me show you. Everybody look up, please. Look at our original equation. X squared equals 0. What was it before it became 0? No, before it became 0. If I was to rewrite it. X squared equals y. Is that correct? Did I show you how to graph these kind of graphs when we did patterns? Y equals x squared, I said, here it is. And as soon as we added a constant, what did it do? It either went up or down. Remember that? Okay, yeah. Okay, let's do another one. Example 1C. Copy that, please. X squared plus 16 equals y. All right, let's see. First steps first. 0 for the y, we write x squared plus 16. Check this out. Inverse operations, we subtract 16, we're left with x squared equals negative 16. From there, to cancel the square, we take the square root, x equals square root of negative 16. Is there such thing in real numbers? No. What is this called? Imaginary numbers, and therefore there's no solution. No solution. Once again, why no solution? Because we cannot take a square root of a negative number. That's why in the quadratic formula, when we derive the quadratic formula, on the numerator, we cannot take the square root of b squared minus 4ac. Remember that? Okay? So, let me show you something. Pens down, please. Let me show you some patterns. Pens down, eyes up here. Everybody look up. We started with this one. What do you notice in between the two terms? A minus, negative, or subtraction. How about this one? Minus, negative, or subtraction. How about this one? Minus, negative, or subtraction. How about this one? Nothing, but we solved using inverse operations, and we did have a solution. So look at this one. What do we have? And what is the answer? So therefore, what do you conclude? Whenever it's a binomial and it's a sum and it's equal to 0, there is no solution. Let me repeat that again. Whenever it's a binomial and it's a sum and it's equal to 0, there is no. Make a note for yourself, please. Whenever it's a binomial, comma, it's a sum, comma, and it's equal to 0. What? What did we say? There is no solution. What? All right. So, with that said, let's go to the next one. Copy this next one, please. Example 2. 2a. X squared plus 7 equals 7. X squared plus 7 equals 7. So right away you're thinking no solution. However, is it equal to 0? No. So therefore for this one there should be a solution. Let's do this together. X squared plus 7 equals to 7. Inverse operations, what do? Subtract 7, subtract 7. X squared equals 0. Take the square root, x equals 0. So where would this graph go through? 0, or the point of origin. Okay. Let's do another one. Number 2b. Copy that one. See if you can do that one by yourself. Go. 16x squared minus 49 equals y. All right, here we go. So, solve using square roots. I substitute y with 0. We're left with 16x squared minus 49. I'm going to use inverse operations. All right, here we go. Inverse operations. I start here, so I add 49, add 49. We're left with 16x squared equals to 49. So, first step was to isolate the variable. Is the variable isolated yet? No, we still have that 16 that's doing what? Multiplying. What is the inverse? Divide by 16. Divide by 16. We're left with x squared equals 49 over 16. What's our last inverse operation? Take the square root. Take the square root. This cancels this. X equals plus minus 7 over 4. Copy that, please. All right. Everybody look up, please. I'm going to go ahead and graph this. Some people are asking, how do you graph that? Let's see. I get my coordinate plane going. And then what's my, let's see, is that a little crooked? Yes, it is. How about that? No. There it is. Okay. What's my root? Let's see. What is 7 divided by 4? 1 3/4, so 1.75. So therefore, my roots are 1.75 and negative 1.75. So what is my y-intercept? Negative 49. So my parabola should look something like this. Yeah. Okay. Copy this next one, please. A 100x squared plus 49 equals 0. 100x squared plus 49 equals 0. Go ahead. Okay, let's see. Who noticed that it's a binomial? Who noticed that it's a sum? And who noticed that it's equal to 0? Therefore, no solution. Why no solution? Because it meets all three things. What are the three criteria? Binomial, sum, and equal to 0. What three criteria? Binomial, sum, and equal to 0. It needs to meet all those three in order for there to be no solution. And if you want to see it, we can subtract 49 from each side. We're left with 100x squared equals negative 49. At the end, we divide by 100. Divide by 100. We're left with x squared equals negative 49 over 100. Take the square root of that, square root of that. Can we take the square root of a negative number? No, that's why there's no solution. Copy this next one now. 36x squared equals 1. 36x squared equals 1. Go.
done with my homework.
Guys, focus. Here goes. What's my last step here? Or my next step? Divide by 36. Divide by 36. We're left with x squared equals 1 over 36. All right. So what's our last step? Square root, square root. We're left with x equals plus minus 1 over 6. Nancy, you got that? Okay. Let's do another one. Copy this one down. Y equals x squared minus 15. Y equals x squared minus 15. Y equals x squared minus 15.
Oh.
All right, pens down, eyes up here. Now, some of you that already went ahead, you probably noticed this. Here it goes. First step. Make it equal to 0. X squared minus 15. Inverse operations. I add 15, add 15. We're left with 15 equals x squared. And my last step, I take the square root. Square root. This cancels this. We're left with x equals plus minus whatever this is. This is not a perfect square. Do you guys notice that? Yeah. So now, remember we did some of this practice sometime back, and I showed you, check this out, square root of 15. What's the perfect square before 15? Perfect square, 9. What is the perfect square after? 16. So therefore, check this out. What is square root of 9? That's 3. Square root of 16 is 4. If square root of 15 is in between these two, that means it's in between 3 and 4, isn't it? So therefore, this is going to be 3 point something. We don't know what that something is, and I'm going to refresh in your memory. Here it goes. Everybody look up. You need to write this down. 15 minus 9. What is 15 minus 9? 6 over. What is 16 minus 9? 7. Now that we have a fraction, can we get a decimal out of the fraction? Yes, we write our division. So this is 6 divided by 7. It does not fit in there. Add a decimal, add a 0. 7 fits in there 8 times. Is that correct? 7 times 8 is 56. Subtract. We're left with 4. Add another 0. Bring that down. 7 does not fit in there. It just fits in there 5 times. That's 35. Subtract, that's 5, add a 0, bring that down. 7 fits in there 7 times, that's 49. And I'm going to stop there because they're asking us to round to the nearest hundredth. So my hundredth place is this one. So this tells me that it goes up to what? 86. If this number to the right is greater than 5, this one goes up to the next number, which is 6. So my decimal value is 3.86. Copy that. What's that? Where at? This one? Yeah, you always go with the lowest number. Let's do another one. Did everybody copy this? Okay. I did say to copy it. Here we go. Example number 3B. Copy this one. Y equals negative 3x squared plus 90. Y equals negative 3x squared plus 90. Let's do this one together. First step, change y to 0. We're left with negative 3x squared plus 90. From there, inverse operation, subtract 90, subtract 90. We're left with negative 90 equals negative 3x squared. We divide by negative 3, divide by negative 3. We're left with x squared equal to 30. Take the square root of this and square root of that. This cancels this, x equals, and then we're going to have plus minus a certain number. So check this out. Here goes the process again. Square root of 30. What's the perfect square before 30? 25. The one after is 36. Square root of 25 and 36, that's 5 and 6. So square root of 30 has to be between these two numbers. So this is going to be 5 point something. Let's find that something. 30 minus 25, that's 5. 36 minus 25, that's 11. So therefore, we got 5 divided by 11. That's why I'm asking you to copy this if you forgot the process. If it's in there 4 times, that's 44. Subtract that 6. Add a 0. If it's in there 5 times, that's 55. That's 5. Add a 0. You notice that a repeat again? So that means it's going to go 45 and 45 repeating. However, they want us to round it to the nearest what? 100th, which is this one. Does it stay a 5 or does it go up to 6? So this is 5.45. So, okay, yeah, I'll check that right now. Homework. Pages what? 585, numbers 1 through 15 odd, and 16. Have a good one, guys. Enjoy your homework. I'll see you guys tomorrow.